Direct Lithium Extraction 2.0, Moving from Innovation to Scalable Supply. My name is Ian Reinhardt, Principal Analyst here at Lux Research, and I will moderate today's session. Presenting today is my colleague Abhirab Basu, Senior Analyst. Throughout the webinar, you can type any questions you have in the questions box on your screen. Time permitting, we will answer all the questions that we can. If your question does not get answered, please do not hesitate to email it to questions@luxresearchinc.com, and we will respond. If at any point you experience technical difficulties, such as a frozen screen, simply try refreshing your browser and check that your internet connection is strong. Before we start the webinar, a word about who we are. Lux Research helps organizations make confident innovation decisions about what matters next. As an independent research and advisory firm, we work with many of the world's leading companies to identify emerging opportunities, evaluate technologies, and make high-impact innovation decisions. Our scientists, engineers, analysts, and industry experts combine original research and methodologies with practical decision frameworks to help organizations separate signal from noise. Every day, we help clients answer three critical questions. Where should we focus innovation efforts? Which technologies deserve investment? And which partners can accelerate innovation? Today's webinar is an opportunity to share some of that thinking with you. Now, I'll turn it over to Abhirab for the presentation.
Thank you, Ian. Hello, everyone. My name is Abhirab Basu. I'm a senior analyst here at Lux Research. I'll be taking you through today's webinar on Direct Lithium Extraction 2.0. But before we dive into 2.0, you're probably wondering, where's DLE 1.0? The reality is DLE isn't new. Direct lithium extraction generation 1 technologies have been operating commercially since the 1990s. The famous plant in Argentina, run by Livent, which was acquired by Rio Tinto pretty recently, has been operating since 1997. Over the last decade, Chinese producers have been quietly scaling those generation 1 technologies and innovating a bit on the next generation as well. So today, the question is no longer whether DLE works. We already know it can. The real question, and the one we'll answer today, is which DLE projects can scale economically in today's lithium market and capitalize on future lithium demand. There's been quite a bit of commercial momentum that's accelerated innovation in the last 3 years. Today, we are seeing three major shifts happening simultaneously. First, outside of your traditional miners or asset owners, we are seeing upstream resource owners, particularly from the oil and gas industry, like Exxon, Chevron, Equinor, enter the lithium market, acquire lithium assets, invest directly in projects. Second, we're seeing oil field service companies, water treatment specialists, integrators, OEMs like SLB, Aquatech, Curita, Cleantech that are building integrated DLE capabilities. And third, we're finally seeing commercial milestones. That's offtake agreements, acquisitions, and companies starting to operate commercial projects. That suggests DLE has moved beyond your demonstrations and pilots. So naturally, everyone's asking the same question. Which technology is going to win? And if we focus on lowering operating costs, does that automatically create the best project economics? Or will the newest DLE technology replace everything that is already being deployed? Those are the exact same questions we set out to answer. And over the next 20 minutes, you'll see that all these three are partially true, and understanding why is what separates commercially successful DLE projects from the rest. So for today's agenda, I want to focus on the drivers for DLE 2.0. Then we'll explore why some projects are positioned to succeed while others may struggle. And then finally, what it means for the industry stakeholders, the mining companies, the chemical suppliers, energy players, and technology developers as DLE enters this next phase. So to start off, we're going to look at the drivers for DLE 2.0, and I want to focus on supply, demand, and policy drivers. Lithium demand continues to outpace long-term supply growth. global demand is expected to reach somewhere between 3 to 4 million tons of lithium carbonate equivalent by 2035. Now, that requires significant investment in new mining, refining, and processing capacity. Historically, we've seen hard rock dominate recent supply growth, especially over the last decade, and brines play a smaller role. But brines are becoming competitive, and one of the big reasons for that is DLE is creating improvements in recovery of lithium, shortening production timelines, and reducing land, water, energy requirements for producing lithium. Finally, DLE is also expanding the supply mode. It enables lithium to be produced from resources that were previously less competitive or uneconomical. So by 2035, we estimate DLE to deliver about a third of lithium supply. The second factor is onshoring and policy that's driving onshoring, because economics aren't the only reason that DLE is getting momentum. Policy is becoming just as an important factor. We're seeing governments are reshaping where and how lithium supply gets deployed. Here in the US, the IRA plays a big role in that. In Europe, this critical raw materials impact aims to increase lithium supply. And we're also seeing other nationalistic policies from South America, which is driving onshoring, potentially trying to de-globalize lithium supply. The West has historically lacked a lot of these lithium reserves and production capacity, but it's now largely responding to threats, largely from Chinese and other Chinese players and other nations, restricting technology, restricting chemicals export quotas. One of the big changes that we've seen since our last DLE report, the last exercise, the DLE 1.0 focus, is that not only has the technology changed, the market has changed as well. Volatile lithium prices are separating scalable DLE projects from speculative ones. Lithium prices have fallen dramatically from their 2022 highs of $82,000 down to about $8,000 or $10,000 in the last year. That's fundamentally changing how projects are being evaluated. During periods of high prices, almost every DLE concept, especially the speculative ones, look very attractive. So today, investors are asking a much tougher question. Can projects still generate acceptable returns in those low lithium prices? And can projects be resilient across the lithium price volatility cycle? So that's what brings me to the second half of our webinar, and what I'm going to be focusing on for the rest of it is how to evaluate DLE projects as they scale. But before we dive into the data, I'd like to introduce a simple framework that explains why some DLE projects succeed while others will struggle. In our view, there's three factors to determine success. We call it the pyramid of DLE success. First is the resource itself. That's the lithium concentration, the impurity profile, the overall quality of the asset itself. That forms the foundation of success, because no technology can completely overcome a poor resource. The second is the focus on the technology and its techno-economics. We're not just looking at operating costs. You have to look at things like capital intensity, how the project is being financed, what are the project returns across those different lithium price environments. And finally, I think one of the key factors that we are seeing today is execution. That's the ability to reliably scale, integrate DLE technologies, the first generation one with more novel capabilities, and consistently deliver that battery-grade lithium. So throughout the rest of the webinar, we'll keep coming back to this pyramid of success to show why some DLE projects are emerging as winners. Let's look at resource itself. So before we go into technologies, resource plays a pretty big role, because not all lithium resources are created equally. The first and the main resource a lot of companies are focusing on today is the continental salars. These are generally the highest quality resource for lithium, relatively high lithium concentrations, and we've seen decades of commercial production from these salars. Second, the next resource are geothermal and oil field brines. These are a lot more dilute resources, often containing high level of impurities, requiring additional infrastructure, pre-treatment costs, and more complex processing. And finally, clays. Clay deposits are completely different. They often take their reference from traditional hard rock mining, so there's a lot of leaching involved. But we're seeing some companies also attach DLE to the leachable liquids that are coming out of these clays to produce lithium. For this exercise, we're excluding the clays from our benchmarking today. So across the study that we've done, we benchmarked more than 50 DLE projects spanning salars, geothermal, and oil field brines at different stages of commercial deployment. Once we benchmark those projects side by side, the first question we get is how competitive are these different resource types? So to do that, I've got a simple chart here. We've got capital intensity on the x-axis, operational costs on the y-axis. The bubble represents the lithium concentration of that asset or that project. If the best technology determines success here, we expect projects to cluster by different DLE technologies, but that's not what we find. After benchmarking these projects, the clearest pattern is that they cluster by resource type and not technology. Notice how salars consistently occupy the lower left to the medium, to the middle of the chart. They combine relatively lower capital intensity with medium operating costs. That's because lithium concentrations are favorable, the brine chemistry is favorable, and the ability to integrate into often existing low-cost solar evaporation ponds reduces that processing complexity, and it's cheaper from a capital intensity point of view. In contrast, your oil field and geothermal projects shift to the right. That's not because the DLE technology is inherently worse here, but because the resource itself demands deeper wells, continuous pumping, re-injection costs, pre-treatment is more. It's a lot more complex surface infrastructure as well. At times, some of these projects need to do offtakes of the byproducts as well to attain a faster payback. So these factors drive capital well above traditional salar projects. But to compare these projects fairly, we can't just look at one metric. We have to look into the all-in costs, and that's combining your operational costs with annualized capital costs. We've used an NPV10 framework to normalize differences in project life and capital intensity. This approach truly reflects the true economic cost per metric ton of lithium carbonate equivalent. And it enables comparison of these projects' viability at today's lithium prices. And once you do that benchmarking, the picture changes dramatically. I want you to focus on two reference lines that tell different investment stories. At low lithium prices, let's go back 18 months, January 2025, we hit a 5-year low in lithium prices, dropping to about $8,000 a ton. At that price, only the lowest cost salar projects generate compelling economics, largely because they benefit from that lower capital intensity, can leverage hybrid flow sheets that often include evaporation ponds, and that lowers the cost of downstream DLE plant. As prices return to today's prices, lithium spot prices over the last 6-8 months have been around $15,000. Today it's about $22,000. As these prices trend towards those long-term incentive levels, more projects become viable. But you notice that the oil field and geothermal projects still sit at that high-end cost curve. Unconventional brines become economically viable only at sustained lithium prices, typically above 25,000, more closer to 30,000. As a result, project returns deteriorate rapidly when lithium prices decline. So that's where these projects become vulnerable. Despite these challenges, we are seeing unconventional projects are still being pursued for strategic reasons. It could be a particular country or a region that wants to build lithium supply, or it could be for ESG reasons, for moving away from hard rock or the high energy footprint of that. Or for one of the more prevalent reasons is strong strategic support from corporates and governments, typically an automotive-backed demand that is sustaining a project. This is where companies are willing to absorb a slower payback, often to build that first-of-a-kind plant in new markets. So that's why resource quality remains one of the strongest determinants of payback. Technology matters, but resource quality determines the economic starting point. The most successful DLE projects are going to be the ones that match the right technology with the resource rather than trying to shoehorn a particular technology into every resource. Now that we've established that resource plays a really big role in determining the economics, let's look at where technology actually creates value. And to do that, we're going to look at the techno-economics of DLE technologies. But first, let's look at the DLE technology landscape itself. This is a process flow for DLE. You pump the brine to the surface, do some impurity removal, then goes to the DLE step before chemical conversion. It's important to remember that all DLE technologies perform the same job. They selectively remove lithium from the brine. What differentiates them isn't simply recovery of the operating cost, it is the selectivity, durability, scalability, and ultimately the execution risk of that technology. So there's 5 key technologies, starting with adsorbents. These remain the commercial benchmark today. They have the highest technology readiness level. They've been used across multiple commercial projects as well. Second are functionalized resins or ion exchange resins that can achieve excellent lithium selectivity. They have longer cycle life, but they are most sensitive to brine chemistries. That makes them attractive for certain resources, lower concentration resources, or the unconventional brines. But they require more solvents and tighter process control. And then we get into some of the more speculative or earlier stage innovations. Solvent extraction has been deployed commercially in traditional mining projects, but for DLE, it remains immature. Solvents do an excellent job in as they offer high selectivity, particularly for lower grade or impurity rich brines. But solvent degradation, reagent losses, more complex mixer settler circuits has limited the commercial deployment. Membranes are an excellent area of innovation. We see a lot of activity in this space, but perhaps not for their innovation is not known for the exact reason. They don't replace adsorption. They're increasingly being used for pre-concentration or in hybrid concentration technologies to remove impurities and simplify the downstream steps. Standalone lithium selective membranes, particularly in electrochemical systems, are still in early commercialization. And finally, biomining. This is a much more earlier stage technology. It's a long-term opportunity. Microbes offer potential for lowering reagent costs, but their recovery rates for lithium are pretty low, and maintaining that biological system in these high salinity brines is a big engineering challenge. Finally, when we talk about hybrid DLE or hybrid DLE projects, we are often talking about combining one or more of these technologies with evaporation or just a combination of these technologies together. And I'll show you what we mean by that. So once we understand what the DLE technologies are, the next question becomes, when benchmarking these in real projects, does one technology clearly outperform the other? So let's go back to that same chart where we look at capital intensity and operational costs for different projects, but now based on technologies. Looking at this comparison, the first thing you'll notice is that adsorbent-based systems dominate the commercial landscape. They tend to acquire that lower to middle cost curve. They're the most mature technology and the most bankable technology. These systems often require desorption and downstream purification. Their operational costs are somewhere between that $4,000 and $6,000 a ton. CapEx for most adsorbent systems are standardized because of the scalable flow sheets. However, front-end processing, downstream refining can be significant and increase costs. Overall, let's say adsorbents today define what is the baseline of DLE economics. They're provable, bankable, but they're not a transformative solution. Ion exchange systems, on the other hand, generally occupy a similar economic range. They are more sensitive to the resource quality, which is why they could be slightly higher in OPEX. They're definitely higher in CapEx due to tighter process control, more resin handling. However, the most interesting thing and the takeaway I want you to take from this chart is hybrid systems are becoming more and more prevalent. that is combining adsorption with membranes, electrochemical conversions, and partial evaporation as well. Those reduce your downstream processing costs. Several projects today are demonstrating that these hybrid flow sheets can achieve some of the lowest operating costs and to some extent lower capital cost as well. But the story doesn't end with today's commercial technologies. Across the industry, we're seeing the next wave of innovators targeting the remaining cost drivers: reagent consumption, energy use, water handling, downstream processing, all of that to push your costs even lower. Historically, direct lithium extraction has focused entirely on getting lithium out of the brine. But refining that lithium into battery grade chemicals can account for a significant portion of your total project cost. Looking across the next generation, that integration of your upstream DLE and refining is the next shift in the lithium market that we're seeing. The next competitive battleground isn't just going to be about extraction. It's going to be about integrating extraction with refining into an optimized flow sheet that will really cut down on both operational and capital costs. Now, looking across the next generation of approaches, we see different innovation strategies. We've got startups like Lilac and Summit Nanotech that are innovating on the adsorbents and ion exchange side to increase resin life, improve higher loading of lithium, and the life cycle of the adsorbents as well. Solvent exchange and extraction startups like Altilion, EcoSolve, Adionics are pursuing newer approaches using things like deep eutectic solvent for very challenging brines, mitigating those solvent losses, targeting low-grade brines where other technologies struggle. And moving further downstream, companies are targeting the extraction and refining in one step. We're seeing electrochemical innovators like Electrolyte, Ionics out of the Netherlands that are integrating membrane and electrochemistry to combine those steps together to lower the processing costs. The opportunity here from an innovation perspective is definitely real, but so is the risk. Nearly all these systems are still at a pilot stage or entering early commercial demonstrations. There's still a lot of questions around long-term durability, replacement costs, maintenance costs that need to be demonstrated over years of continuous operation. And I think by that time, the winners might actually change in DLE. They might not be the materials or the OEM. It could be the integrated system providers, the companies that have demonstrated integrated capabilities in other mining projects or in oil and gas industries. Companies like Saltworks, Aquatech, Tetra Technologies, Water Cycle Technologies that are combining different integrated approaches to optimize that extraction and refining system. So after benchmarking these DLE technologies and reviewing the leading technologies, we're seeing that to climb that pyramid of DLE success, you need to do three things simultaneously. You need to figure out the right resource. You need to look at the project that works economically, not just the DLE technology that is lowering costs. You have to look at you have to do a competitive assessment across key financial metrics to be less vulnerable to those volatile lithium prices. And finally, I think the most important part is what we're seeing today is execution. We're going to see a combination of proven DLE approaches integrated with novel system design or emerging technologies like those electrochemical refining systems to build integrated flow sheets. But at the end of the day, operational reliability will ultimately determine which projects get built. And once you start thinking about DLE through this lens, the roadmap for key industry players and stakeholders becomes much clearer. If there's one message from today's webinar that I want you to take away, if you're a chemicals and materials company developing a new sorbent, if you're an energy player incorporating DLE into your energy transition roadmap, if you're an EPC or an OEM integrator looking at new business opportunities in the lithium market, I want you to think that success in DLE won't come through a single breakthrough technology. There's no silver bullet here. Winners are going to combine those advantaged resources, look at the proven technologies over there, maybe integrate some novelty in their design, and then focus on execution. And so for my outlook and what I want you to focus on today is execution. For materials companies, that's about commercializing today's adsorbents and ion exchange systems while working from an R&D perspective on improving the durability, selectivity, life cycle of these adsorbents, and then integrate them into your service offerings in the future. Energy players, that means you have to focus on advantaged resources and proven flow sheets rather than chasing the new chemistry or looking at very low complicated brine, low lithium complicated brines. And for integrators and OEMs, the opportunity is to build complete system capabilities. Don't offer a single individual piece of equipment today. Over the next 2 to 5 years, what you're going to see is a shift to scale up, right? We expect geothermal projects to become more increasingly important as costs decline and financing improves. Materials companies are increasingly going to start looking at differentiating through partnerships, maybe offering integrated solutions and service offerings over there, rather than just the standalone material. At the same time, integrators will begin combining that extraction with downstream concentration, refining, maybe water treatment. Zero liquid discharge is becoming pretty key in some of these flow sheets, with the aim of deploying modular flow sheets. And looking even further ahead, this is through to that 2035 timeline, the opportunity broadens. As technology matures, companies can expand into more challenging resources. I'm not telling you to do petro brines or oil field brines today. We don't see that becoming necessarily commercial in the next few years. That's going to take time. Start looking at those oil field brines in the 2030-35 timeline. Similarly, geothermal brines, eventually clays start playing a bigger role as well. Material suppliers are likely to consolidate. They move towards project revenue sharing model. You want to not just supply the resin, you want to take a bigger piece of the pie by investing in the asset itself. And then integrators start looking at replicating what you've built in the last few years as successful platforms across maybe different geographies or adjacent lithium markets, where you can look at battery manufacturing wastewaters where there's lithium sulfates or battery recycling waste streams. Alternatively, you could look at other critical minerals where there's waste streams that would require similar flow sheets and similar extraction refining capabilities. Ultimately, the winners won't be, again, a single DLE approach. It's going to be how you combine a resource with the existing technologies, and then really importantly, focus on that execution. That's it. Thank you, and I'll take some questions now.
Thank you, Abhirab. Fantastic presentation. We will now be taking questions from the audience on the presentation, which you can type into the questions box. And if we do not get to your question on this call, someone from Lux will be in touch after the webinar. So first one from me while we wait for those to trickle in. There have been a lot of announcements regarding DLE projects recently. Do you, Abhirab, think we're at an inflection point for DLE, or is commercialization still several years away?
Yeah, I think that's a good question. I think we are at an inflection point. It's less to do with the technology getting there. The first generation technologies are proving commercialization today. I think it's that ability of, let's say, a DLE company working with an EPC or a project owner to start executing and start building those plants. That's where the inflection point is. And the ones that are doing it are largely focused on very healthy resources, and proving the economics over there so that they are locking in offtake agreements as well. So yes, that we are at that inflection point. It's less to do with the technology, it's more to do with how they're executing with the solutions.
Okay. Then one from the audience here. You talked in the webinar about the innovations in membranes, solvents, ion exchange, electrochemical approaches. Do you see these as competing technologies, or are they more complementary?
Yeah, that's a good question. They do seem initially competing, but they are likely going to be complementary as those hybrid DLE flow sheets start dramatically lowering costs. These could be more complementary in solutions. Again, it will come down to whether that technology is useful at that resource. Do you need to use a slightly more expensive electrochemical electrodialysis or bipolar electrodialysis system over there, or can you get away with just using membranes? So it does come down to the kind of resource that you're dealing with, the impurity profile, the concentration of lithium. And we're seeing that those hybrid flow sheets are actually using membranes as pre-treatment, post-treatment, and then using electrochemical concentration. So I would say a lot of these technologies are going to become complementary.
Okay. The next question must be from a material development company. As DLE matures, do you expect value creation to come from breakthrough materials or from integrating existing materials into more efficient extraction and refining systems?
I think innovation on the material side is going to continue. I feel that there is a driver for that, and that is reducing costs, that is improving durability. But to meet that future demand, I think you're going to see existing materials and innovation go into integrated approaches. And you know, it's going to be a system level approach to lower overall costs. That's where I think these integrators, like examples that I've brought up, like Aquatech, for example, they went and acquired Coke separations ion exchange technology, and now they're putting other bells and whistles around that to build an integrated solution, offer an end-to-end solution there. So from a material supplier perspective, I would say focus on today, but keep a foot in the future, looking at durability, cycle life, higher lithium loadings, and start testing those and incorporate those into your future offerings. But focus on the ability to integrate today.
Good, okay. Well, let's do one more question since we have just a couple more here before we run out of time. Are we at a point where mining companies need to adopt next generation DLE technologies, or is there still a case for sticking with the more proven approaches?
Some larger brine miners are still doing evaporation only, but you're also seeing them now start investing or doing a small scale pilot of DLE on their brine evaporation ponds. I think miners need to look at DLE as a solution that will optimize their existing assets, and then start using purely DLE in the new assets that they're acquiring. I think there was a slide where there was a Rio Tinto executive that you know specifically mentioned that DLE is going to be the next big thing. I think that's true. You're seeing companies like SQM through their ventures team start investing directly in DLE startups. BHP Ventures is an investor, I believe, in Summit Nanotech. So you are seeing that happen with the miners that are often very super bottom line focus, start to venture into the investment space and start demonstrating as well. So yeah, this is high time before they get kind of left behind.
Great. Well, thanks for taking all those questions. And I think we ought to wrap up and finish on time here. So thank you, Abrob. That concludes the webinar for today. The slide presentation and recording from this webinar will be sent to all attendees via email. After leaving the webinar, you will be prompted to complete a survey on today's presentation. We would appreciate any feedback you may have to help inform and improve future webinars. So please take a moment and check out our upcoming webinars on the website. Thanks for joining us and have a great day.